Good morning and welcome to today's virtual breakfast briefing. Thank you very much for joining. Delighted to be running today's briefing in partnership with Juniper Networks. And today we're going to be discussing the power of the AI workplace with a real particular focus around the wireless network and looking and exploring some of the changing demands of the network, as we prepare for the return of the workforce following a sustained period of home working and remote working. So going to hear some views from Mobliciti, and delighted to hear some views from the Juniper team as well. And we'll also show some of the Juniper Mist-driven technology as well, which would be great to see. Right, so if you move on to today's agenda. So quick introductions in just a moment. We'll have a look at, I guess, the back to normal, whatever that may be, or is it moving into the unknowns? Andy's going to discuss some thoughts there. We'll also explore the network for the next decade and give our perspective of what we think that's going to look like. And then we're really going to get into the meeting today with exploring the AI-driven, cloud-enabled and agile technology with the Juniper Mist solution. We'll close things down. Hopefully there'll be some questions at the end, and hopefully a useful hour or so. So if you have a quick look at today's presenters, obviously myself, so Ashley Dell, Head of Sales here at Mobliciti. I think I know many of you that have joined this morning. Andy Brown, our Chief Technology Officer here at Mobliciti, and delighted that we've got Phil Keeley, Senior Systems Engineer over at Juniper, who's going to be giving the perspective from Juniper today, as well as showing some of the tech in action. Right, so very quickly, for those less familiar, I think many who've joined today know who we are, but as I say, for those not so much, that Mobliciti, 12 years focused exclusively around mobile IT, cloud and connectivity. These are three core pillars which we've been delivering into our client base since inception. And we've got an enterprise client base with a real strong presence in legal and financial services. So we're not prohibited to those two alone, but a lot of the highly regulated and security conscious organizations entrust Mobliciti to help deliver against their mobile cloud and networking strategies. And what we do, we deliver an array of different solutions and service and managed service, award-winning range. And it's all about helping our customers to bridge any skills and resource gaps that they may have within their teams, because most organizations don't have huge technology teams today, but still have massive change agendas that they need to deliver against. So for us, it's helping to bridge those gaps, help them deliver against their cloud and their mobile IT and their networking strategies. And do that, regardless of location, whether that's home office, but for today's session, more around the corporate office, whilst maintaining security and trying to keep costs down as well. So that's 1,000-mile high view. A little bit more detail towards the back end of the session around some of the specific areas, but hopefully that helps to set the scene from a Mobliciti standpoint. And at this stage, to really set the scene for today's briefing, I'm going to hand over to Andy.
Morning, and thanks, Ash. Morning, everyone. Thank you for joining us. The idea of today's session is to really start to think about, this kind of concept of back to the normal or into the unknown. The big summary point is actually a hell of a lot has changed in the last, it's more than a year now, let's be honest. We're kind of getting up to the 18-month window now. A lot of businesses have really quite dramatically transformed the way that they work. And, clearly it sounds obvious, but everyone was sent home. Generally, they were sent home, they kind of carrying sent home with a laptop in many, many cases. But the way they actually worked has changed pretty substantially in that time. And the actual shift in technology has obviously been, these are obviously the headline things that we've started to see happen. These were things that were generally in flight in organizations anyway. kind of this, there was a shift towards people carrying their computer around anyway. There was obviously all of the solutions for video collaboration already existed in many organizations. It was just that there was an explosion of actual usage of it. But crucially as well, the reason that this explosion happened so seamlessly was that effectively it was, the big jumping off point where, the power of cloud adoption and the ability of cloud services to ramp in the background all meant that you were able to carry on working pretty much as normal. One of the key things, though, was the fact that by sending everybody home, in many cases, you ended up with a kind of WAN bypass going on. The traditional WAN network inside many organizations has effectively been dormant for the last 18 months or so. People have either been going direct into cloud services from their internet-connected home networks, or they've been tunneling back into VPN gateways and then out again, depending on how the network architecture exists today. And the whole underlying shift that I think a customer summed up quite nicely is what's starting to happen now is work is becoming something you do. It's not a place you go. It sounds a little bit, high level, I suppose. But, the fact is, though, that as we see people starting to return, the office is actually becoming an important building for the opportunity for staff to actually congregate again. More than anything else, an office space isn't defined by its networks and its security perimeter and all of the various things that you'd think of from an IT perspective, but it's actually fundamentally, it's a congregation point. And if people are arriving at this congregation point with their own power compute, with the ability to work anywhere, anyway, that potentially gives a really interesting moment of reflection on how the network itself is going to be designed. Because the staff are definitely coming back. I mean, many firms I'm talking to are soft launching at the moment, if you like, across the holiday period. But clearly, there's some genuinely quite hopeful news in terms of numbers and the way vaccines are starting to work. The general plan is people are talking about September as the kind of the grand return, if you like. And the point we make here is all of the change that's been implemented in the last 18 months is about to hit the network as it was 18 months ago for the first time at volume and at scale. And crucially, the demands on, in particular, the wireless side and the WAN design side, they're about to make a significant step change. The way that people have worked, the way that they are potentially going to want to move around the office, they're going to want to video collaborate, they're going to want to consume more cloud services. It's a big change. And in parallel, as I kind of mentioned, people in the building are likely to start shifting around more. We've seen this ourselves, and Mobliciti have started to reopen our offices, and we're seeing that what tends to start to happen is people have got used to video collaboration. That doesn't stop once they're back in the office again, because there'll still be a blend of people in and out of the office. And there's a lot more diving for private spaces to have a conversation rather than just doing everything at the desk. Already seeing that. And the point we also make is for many firms obviously have areas that are specifically for when guests come into the building. The guests themselves have also changed the way they work, and the way that they're going to, the demands they're going to place on the infrastructure when they arrive have also changed. And crucially as well, on the whole, things have worked really well whilst people have been working from home. You've had this kind of, the load has been distributed out across lots and lots and lots of private networks at home. And their expectation of how video collaboration works and how VoIP services on a headset work and everything else has been set by the lockdown experience. And clearly, they're going to expect it to be at least as good or better when they return to the office. And this is one of the interesting points that we kind of talk about now, which is obviously user experience. Most firms will have, a plethora of dashboards of telling them that their infrastructure is up or down, and that they're getting, everything, that the network is available, if you like. And this is where the Mist AI capabilities and Juniper networks, that we're going to touch on in a moment, can really start to bring something to life. Because on the one hand, you can have dashboards that are genuinely, all good, but on the flip side, potentially you've got this kind of picture being seen in the office. And this is a kind of, everything gets blamed on the Wi-Fi. It's like the Wi-Fi is rubbish. I can't connect, this doesn't work, whatever it might be. That is obviously not necessarily specifically about Wi-Fi. It might be the Wi-Fi, but there's a whole heap of things that tend to get lumped into this. If the computer doesn't work as expected, or if a connection doesn't work as expected, it's just like the Wi-Fi is crap. That kind of thing just happens as a rule. And this experience can often be quite hidden. People just get frustrated and give up, or people will just moan about it quietly. They don't like getting stuck on calls with help desks when they report an issue, because the first thing that IT are going to do when they speak to them is like try and replicate the issue, and then suddenly it works this time. That kind of thing just is immensely frustrating to end users. So how do you actually start to get visibility into what the user experience is vital as you go forwards now? Because if you think about business critical conversations like video calls, VoIP calls, they're very sensitive to network connectivity in general, and so it's important to actually start to get a metric on how things are going. So with that in mind, I'm going to hand over to Phil now, and he can take you through the Juniper Mist AI world in much more detail, and we can start to bring to life the way it can potentially make life easier.
Cool, thank you very much. So yeah, my name is Phil Keeley. I'll be taking you through a little bit of this. If I can find my camera, I will turn it on. There it is. Okay, cool. So yeah, as Andy said, I'm going to take you through the Mist Juniper story, focusing around the AIDE, Artificial Intelligence Distributed Enterprise is what it stands for, in case anyone was wondering. And we're going to cover sort of two main areas. The PowerPoint is looking at the network for the next decade. We're literally trying to define how wireless and wired networking and WAN networking, in fact, is going to happen over the next sort of 10 years or so. And then we'll look at the AI cloud-enabled concept and what that actually means. So where did Mist come from? Why did Juniper buy Mist? Well, Mist came from our friends at Cisco, basically. Most of the guys working who formed Mist were running the Cisco wired and wireless business. They're the guys who bought Meraki several years ago. So you can see there, Bob Friday was the guy who invented the airspace controller concept, which is what Cisco has been putting its business on for the last 20 odd years. So these guys have all been in the business, and everyone inside the Mist part of the environment have been in the business for sort of 20, 25 years. So we are very aware of the slide that Andy finished on, as far as the person tearing their hair out on the shop floor. And this is because wireless is a tough nut to crack. So they wanted to start applying AI inside Cisco. Cisco said, we've already got too many wireless products. You're not creating another one in here. So they all left, basically, and formed Mist with the sole intention of solving that customer experience, that user experience. What could they measure? What could they do to understand how the user experienced the network rather than how the network experienced the network? If you think of where we are today in a wireless world, where the connection from the laptop to the end user device to the network is over effectively a shared medium. We've gone back 30 years to hubs. You think where you might have come from 5 years ago with a fixed wired PC to a fixed switch to a fixed router to a leased line across the internet to your own data center. You can put a packet on that network and know how long it takes to get to the other end to within the millisecond. You're in complete control of that network end to end. It's expensive and it's relatively slow. We're now in a situation whereby you're looking at SD-WAN in the the wide area space, and you're looking at Wi-Fi as the front end connection. So you now introduce two completely uncontrolled, well, not completely uncontrolled, but significantly less controlled mediums in two critical parts of your network, all for convenience, cost saving, and speed. All very good reasons, but we need a different way of measuring the user experience and measuring the ability of the network to satisfy that end user experience, and most importantly, recognize when it's not working. So that's what the intent was, and that's what they delivered, and that's exactly why Juniper acquired us. Not because we produced an access point, it's a white box with a flashing light on the front, it's very exciting, but because of the cloud and the AI that is able to take huge amounts of data in, but draw actual human conclusions. If we look at some of just a few of the customers worldwide, these are some very big organizations who've put their trust in Mist and Juniper. So Walmart was Cisco's biggest customer. They're rolling out 2,500 access points a day. They're up to about 170,000 access points now running on our cloud. Gap was Meraki's biggest customer. They rolled out Mist over their Christmas lockdown period. I mean, these are retailers, admittedly, but their business does not run without Wi-Fi. Yeah, and we're starting to see, in the carpeted space, that it's getting to be the same way. Retail is where Wi-Fi started. That's what we were doing 20 years ago. We were connecting handheld computers to networks so that we could keep the stocks up in the shelves. That was the the origin of Wi-Fi. But now that reliance on Wi-Fi that the retail sector has had is very much coming through to the office space. So ThoughtWorks, you can see up there, is an international software developer house, and they have offices literally everywhere from China to Australia. And they've got about 8,000 people worldwide, and they do something like 40,000 Zoom calls a day, because the only way they talk to each other and talk to their customers is through Zoom. And all of that is done over Mist Wi-Fi. There is no wired connections in those offices, and these are software developers. There are no servers in their environment. In the UK, if we look at the market here, we've got some fairly big organisations. So Ocado are a fairly established customer for us, but the likes of Tesco have just signed up. BP have started their rollout. They're rolling out 18,000 sites. But the NatWest Markets and CETA and Indeed are more office-based environments. So we're definitely widening out of the core markets into other more carpeted space, because the requirements are actually just the same. So what's the goal? Why are we partnered with Juniper now? Well, yes, we did wireless, and Juniper didn't have a wireless offering, so it was a good fit. But we are very much open and programmable as a cloud. We are API focused. That doesn't mean anything to most people, but it's actually quite important. It means we can integrate with other things. So BP, for example, are doing their rollout entirely from ServiceNow. Now they create a job on ServiceNow and say, I want to install a new site. Everything else happens automatically in the background. It takes them 12 seconds to deploy a new site. They still have to screw things to the ceiling and the walls and stuff, but the actual configuration element is massively reduced. And as we see integration with other platforms, the migration to a full Juniper stack can be made much easier. But it's all about optimizing that end user experience. That's the whole principle of what we're trying to do, and using the AI to improve and simplify the operations and support model. So where we are now is effectively we've already, in 2 years, we've taken over the wired part of the Juniper portfolio. We're now running that completely inside the Mist cloud, and the SD-WAN is on the horizon. It's going into alpha this quarter, beta next quarter, release in Q1 as the current timeframe. But the reason we want control of everything is we want Marvis, which is our network assistant, to be able to have visibility into everything. So we can ask Marvis, why is my Zoom call not working? And Marvis can look at all of the elements of that Zoom call, all of the components, all of the traffic path that Zoom call has taken, and come up with conclusions without having to understand how to do all of the technical things that you need to do in order to do that. So this is where we will be by the end of the year. A lot of it's already here, but this is the intent. So you will just simply say, tell the system Abby's team call is bad. So there's something wrong with Abby's team call. The system will then talk to the SRX, the firewall, and using the session information will show all of the Teams calls that have happened in the last 24 hours or 7 days or whatever you want to look at. And so It allows you to select which Teams calls has an issue. It will then plot the path that Teams call took. So from the client to the access point to the switch to the firewall. And it will at this point give you a conclusion of what it thinks the problem is, i.e. there is high latency on the firewall. But there is an exclamation point over the access point as well as over the firewall. So you can drill into that and it will show there was some interference, but we don't think that was the thing causing the problem. What we think the problem is the firewall, and you can go into more details and you can see that it's a slow response from the application server. So that root cause analysis is being done by the system all the time. So when someone has an issue, the most expensive thing you have is your staff. The more time you can save when they have an issue to understand what that issue is and get to a root cause analysis, the quicker that person is back earning revenue rather than chatting to the help desk. And that's what this is all about. It's all about increasing that speed with which you can address customer issues. And of course, once they have confidence that you can address those issues from a support function, they're going to call more often, which is a double-edged sword, but they're going to spend less time logging onto their 4G hotspots on their phone and basically trashing the network even further, because that all takes bandwidth of the Wi-Fi environment. So this is what it's all about. It's about being able to support people much faster. But it's actually even more than that, because the system will allow you to see issues long before the end user calls in. That's the point. We want to change from a reactive to a proactive support model. And these are just some of our customers who are seeing huge changes in their business based on that. So if we just show the actual figures here, you're talking about a 96% reduction in support time for a UPS. Now they're a post office. They're a bunch of guys sorting parcels in a hub somewhere. They don't have IT support, but that's not unusual for a satellite office to have no IT support. What they used to do when they had a Wi-Fi issues, they put a guy in a van and sent him to site. Where now they can fix the majority of those problems remotely because they have the data. If we look at ServiceNow, again, they've gone from 100 tickets a month down to 2 tickets a month. When we showed Tomo Mekti this presentation, he said, well, great, so I'll never have another service ticket, right? Because you can tell me the problems and I can fix them before the end users ring in. We're 98% of the way there, but he wants to get to 0 tickets. And the reason they have that is because the support team look at the platform in the morning and say, okay, who's having a problem? Ask the system who's having a problem. It lists all the people who are having issues, and they go through and they fix those issues before the end user even thinks to call in. And they call the end user and say, you were having your Wi-Fi got a bit slow today. We fixed that problem, just to let you know. And you imagine the end user relationship with support desk when they're ringing, the support desk are ringing you to say, you had a problem, we fixed it. Or you're having a problem, we are fixing it, rather than you having to ring the support desk and tell them a whole load of information to try and convince them you're having an issue. So customers say nice things about us, which is always a good thing. But we're still pretty much the new boys on the block. However, the likes of Gartner and those sort of people are starting to see what we're doing is absolutely the way forward. The microservices cloud architecture, as minimum amount of hardware as possible on site. It's a service that you're buying. You don't have your own generator to produce electricity. You don't have your own well to produce water for your office spaces. Why should you have a bunch of infrastructure to make the Wi-Fi work? It's exactly the same principle. We'll run all that back-end cloud infrastructure for you as part of the Mist platform. You buy the plug sockets, effectively the access points to stick on the ceiling, and everything else is our problem. We upgrade it, we control it. And that principle of Wi-Fi as a utility, pretty much, is absolutely seen as the way forward. Offices, businesses in general are starting to not be able to run without Wi-Fi. So it's important that it is treated as an essential service, and that's exactly what we're trying to do here. So the best way to talk about this stuff is to actually show it. So we're just going to jump onto a couple of systems and have a little prod around. None of this is rehearsed, right? We just jump into a system and have a look around. So I say that because most of the time it works, but we'll just see what we can see. So this is Juniper's offices worldwide. So this is the California site, which is our biggest site. And you can see we've got 142 switches on here. There's about 600 access points, about 50 users typically. One day One day it'll be back to the 7,000 or 8,000 people that used to be there. But you can see here, we can see all of these switches, and we can drill into the switches, and we can see the usual sorts of information about the switches. And this is great. This is nice. We can see a stack. We can see configuration of the switch. We can control it all. Brilliant. There's 142 switches on the site. How long have you got to go through these switches to see if there's any problem? Equally, if we look at the access points, 641 access points on this site. Okay, we can show you the ones that are disconnected and why they're disconnected. That's fine. You don't have time to go through all of this stuff. So this is where the service levels come in. So the service levels will allow us to look at this site and see how the end user experience is for this site. And these are, we gather about 150 different elements about a particular client, but they are translated into these 7 service levels. So how long is that device taking to connect to the network? What's the throughput of that device? Is it capable, or is the network capable of delivering the throughput targets that you've set? Is the device failing to connect at all? How's it roaming? How's it moving between access points? Because all of these are critical pieces of information to make sure that end user is having a good experience. Are they having bad signal issues? Are they having coverage problems in a particular area? So these are human experiences. And the whole idea is that you can come into this platform first thing in the morning and say, okay, well, who's actually having a problem? And let's go for the last 7 days. So which devices are having issues? And over here, we can set targets. These are all that you configure. I want my clients to connect within 2 seconds. That's, or in technical terms, it's association, authentication, DHCP, DNS, and ARP in the default gateway. So it's 5 distinct things that client has to do. Now, we're a Wi-Fi access point, right? We're nothing to do with the DHCP. However, if that client doesn't get an IP address from DHCP, the client will report failed to connect to the wireless network. So who do you think they're going to blame? They're not going to say, oh, the DHCP server is not functioning correctly today. It's Wi-Fi sucks. Call the Wi-Fi guy. Right? So if we're going to get blamed for this stuff, we're going to monitor it and understand whether it's an issue. So we've got this target here set at 2 seconds. We don't care about the clients who've connected within 2 seconds. They're having a good day. They're meeting the target, move on. And that's really where the platform gets a lot of its advantage, because the access point can make all those decisions. The thing on the ceiling is doing a lot of analysis for us. So we don't have to push a load of information to the cloud unless it's actually failing your service level that you define. So the 7%, they still connected, but they took a little bit longer than 2 seconds. And we want to understand why they took longer than that 2 seconds. So over here, we've already started the root cause analysis. We're already looking at why clients are failing to meet that 2 second target. And we can see the majority of the problems are around DHCP. Let's have a look at those. So here we can see the DHCP issues, and we then got sub-classifiers to see exactly what's going wrong with the DHCP server. Oh, so sometimes it's unresponsive. Now you've got to remember, Wi-Fi is a massively unreliable medium, to be honest. You throw a packet in the air and hopes the other end catches it. That's kind of the principle. So packets do go missing all the time, and we don't want to report every time we missed a packet. Otherwise, you're going to end up with 100,000 errors, and you're never going to get to the point of what matters, and that's the critical point. So here we can see, there's a lot of users being impacted by an unresponsive DHCP server. We can see the timeline of that. We can see the distribution of that. And what we can see here is we can see which access points are having the issue, which wireless LANs are having the issue. And the anomaly detection is where it gets interesting, because the anomaly detection is looking at baselining everything. It's saying, okay, well, on the Easy Connect, which is our main corporate network, what's the normal rate of failure of DHCP on a Monday morning between 8 and 9 for the last 2 months? And this Monday morning between 8 and 9, what's the actual failure compared to that last 2 months? So it's automatically baselining and saying, okay, well, it's actually a little bit better than normal. 0.8, 1.0 is exactly the same. 0.8 is a little bit better. Here, it's a little bit worse on the guest access. But this kiosk one obviously has a big issue, and this GSKO one has a huge issue. But that's a very small amount of the overall problem. Yeah, it's failed. It's only had 9 attempts, and it failed 3 of them. So you have to take the percentages have to be taken into consideration. That's why when we hover over them, we actually show you the information. So we can drill into that very, very quickly, and we can see which devices are being affected by this. Now, this is like a list of like 400 or 500 devices, so I'll have to give it a second to build that huge list. I should have gone onto a smaller system to show this, but it's still relatively quickly to build a list of 704 users that at some point are having a slow response to the DHCP service. Now, here we can see how much of the problem they are and who's actually failing all the time. So this Kirti's MacBook Pro is actually failing to meet that target 100% of the time. So well, let's drill into that one. That's always going to be a fun one to look at. Now, this is where Marvis comes in. Marvis is now going to look at all the problems this device is having across all of the issues that we're looking at. And yeah, he's having a slow response on DHCP server. We kind of knew that because that's the problem we were looking at. But we could have got here because Kirti had actually rung us and said he was having an issue. And we could have got here in exactly the same way and say, oh, well, you've got problems with your DHCP server. Let's look at that problem. But he's also got some coverage issues. He's got a weak signal strength when he's near this access point. But it's not a widespread problem. It's only actually affecting this client. So this is your first line help desk response, where you can use the system and sound like you were an expert and you've done a huge amount of analysis on their platform, when all you've actually done is click on their device and see what the problems that device is having. We can then jump straight into the real detail behind this. And here we can see the individual events that we're tracking, and we can see some authorization fails here. And what the system has done is already got a packet capture. Now, you're probably not going to care about this, but the guys at Mobliciti who are providing this service to you will care about this a lot, because when they are actually looking for problems, a packet capture helps an enormous amount to see what actually happened. So those packet captures are captured automatically by the platform. There's no payload, there's no data in there. It's just the header information. But that will allow them to see very quickly what's actually happening on the network and why it's failing. And you know, we get a huge amount of information in here, but we get that information right from that initial association. So even though the failure happened way down here, 39 seconds after the initial connection, we're capturing the data all the time in the AP, and it's cached like a dash cam. And when there's a failure, it'll go back through time and upload all of those packets that led up to that failure. So you've got the full packet capture of the initial connection all the way through to the failure. So you don't have to recreate the issue. The issue is laid out for all to see. So here we can see the identity was requested, the identity was responded, and here we can see, here's the identity that he's actually using. We can see the communications, and here we can see the failure, and basically he's getting the password is wrong. Yeah. But he then tries again, and we get the response again, and you can see him trying over and over and over again, and seeing these failures coming through. So the platform makes it very, very easy. You know, when this guy rings up, I can actually say straight away, your passwords, you need to change your password on your device, or your password's timed out. I can then look at the Active Directory or whatever the password system is, and reset his information. So the length of time it would take me to fix this guy's problem, because I can see everything about his issue, is going to be massively reduced, rather than my laptop doesn't work, is all he's going to tell me. I can't get my emails, or I can't launch the web browser, or whatever it is. At the end of the day, we can see straight away exactly what this guy's problem is, and that's the whole crux of what we're trying to do here. So those service levels that we showed for the wired space, sorry, the wireless space, are applicable equally to the wired space if you put in the Juniper switching architecture. So again, across those 100 or so, or 146 odd switches, we can drill into straight away which devices, or where are the problems. I mean, we're pretty good at 96%, right? We're hitting the targets, but we can go into the congestion and see the distribution on that congestion, and see exactly, which switches are actually having congestion and which switches are having problems, which VLANs, which switches, which interfaces. And you can cut and slice this information as much as you want to understand where those problems happen. And this is what ServiceNow are doing. This is what their IT teams are doing, because no one's ringing them anymore because they don't have any problems. They actually have the time to actually go in and fine tune the network. That really brings us on to Marvis. So Marvis is an environment that allows you to ask questions on the platform. I'm just going to go to one of our other systems. Actually has some problems. There's nothing worse than showing a system it's all perfect and everything's fine. That's not where the Swift system is useful. So this is Marvis. And this is Marvis Actions. This is effectively the system looking from client to cloud and looking for actual issues across your entire organization to see where there are problems in your environment. So there's some .1x failures, we know about those. We can see exactly when they are happening. We can see, exactly where the system thinks the problems are with those. There's some DHCP failures. Again, we knew that was an issue. We can see exactly, again, there's the anomaly detection engine working. There's some access points. There's one offline and there's one that's non-compliant. It's running the wrong version of firmware compared to what you've specified as the version of firmware you want to use. So there's some bits and pieces here that we can actually look at. Health check failure is an interesting one. So the access point is a piece of hardware. It will fail eventually, all hardware does. But what we're doing within the cloud, and this is part of the AI, is understanding which components of that access point are hanging or failing. And we're resetting those components dynamically. Now, that's AI. AI is making changes and fixing things without asking you a bunch of questions first. Since we've implemented that, we've seen a huge drop in our inbound calls. Because access points are susceptible to interference. They're looking for tiny amounts of radio energy. And there's huge sources of radio energy in the office space. The microwave oven, for example, is an enormous, it's billions of times more powerful than what's coming out of an access point. So because we can reset these individual components in the access point, we can also predict the failure point of that access point. So with Marvis, we can actually send you an advanced RMA to say, well, this access point is going to fail in the next 6 weeks. Please replace it at your convenience and send us the old one back. And we're doing that on a regular basis now. I mean, they don't fail very often, to be honest, but when they do, we can actually get ahead of that failure and send you the access point in advance. So you get to replace it when it's convenient for you rather than waiting for it to be service impacting. Same on the switch. We're checking for VLAN configurations, bad cables. So we've got a physical cabling issue here, negotiation mismatches, loops, spanning tree, all of the things that could go wrong on a network. We're actually validating and checking these through the AI engine all the time. So the morning routine at ServiceNow and Gap and all those sort of things is to come in here and see if there are any issues that they can address quickly. And if we do look at our corporate environment just for a moment, if I can get that. Right. So we can actually see across, we've got, well, let's just see how many, what the size of the environment is. So we've got 1,600 access points, we've got 455 switches, and we've got 36 SRXs across that network, across the worldwide environment of Juniper. If we look at Marvis, we can see there are 49 things that need fixing. So there's some access points with bad cables on them. There is some access points that are offline, some that are on a version of firmware. There's some port flapping. There's a couple of ports that are flapping, one in California, one in wherever, Maine, is it? Massachusetts? I don't know what MA is. And then there's some negotiation mismatches, some in India, some in Asia, in Beijing. So we can see across that huge environment, there are 49 things for IT to address. How could you get to a situation where across such a large environment exactly where you need to focus your resources? And that's what this platform gives you. So we will end on playing with Marvis's conversational interface. So this is Marvis as a chatting feature. We're starting to see Marvis get involved in support tickets by joining Slack conversations and that sort of stuff. You just ask it questions and it will come back with responses. So, the classic one is unhappy clients or Wi-Fi sucks or whatever else, and it will go away and look across the whole organization and pick which devices are having the worst problem. You go straight into that device and it will give you a very quick summary of what problems this device is having. So he's got some Wi-Fi interference and he's having some DNS results, DNS issues. The client's not even connected at the moment, but we can still find out that he was having bad problems. We can literally, troubleshoot an AP. and it will start asking us questions. It will pick the worst APs that it thinks there are. But if I think that I want to troubleshoot a different AP, so over here we can look at all the APs. So what hasn't it chosen? So let's go LDJSWAP. So I'm now actually having a conversation with the system. So let's pick a client. Let's save that device. So it will then literally go through and love demos. Find it. Troubleshoot that one. There are no problems with that device. So it's much better when you're actually finding an actual problem with the device. Let's find a device that actually has an issue. Okay, he definitely has a problem. So there we can now see that he's got some association issues, some throughput issues. And again, you can look at the timeline of that, the client insights of that. So you can literally find a device by its MAC address or its name or the username or anything that you can find. And then you can see the scope of that impact. So how widely that device is being impacted, which operating systems are having the issue, which wireless LANs are having the issue, which bands are having the issue. So it's a very powerful tool to be able to take any information you've got from the end user and try and find their client and find out any issues. But you can also use this to find documentation and how do I set up Aruba ClearPass, for example, and it will go away and find documentation on how to integrate with Aruba ClearPass. So it's really an interface that allows you to access lots of information about Mist, and it's whatever question gets asked of this platform. If we don't know the answer, it does get sent back into the back-end team, and they teach it the answer. They teach it what the actual answer, what the response is to that particular question. Hence, you can ask it how it is. An amazing number of people ask it how it's doing it. I think it's starting to take on too much of a personality. So that was really the main points I wanted to cover today. We can go through more detailed demonstrations and answer some specific questions if required. But hopefully that's given you a very brief overview of the sort of capabilities of the platform. Back to you, Andy.
Great stuff. Thank you very much. Phil, just get my video back on. So yeah, thank you very much. Fascinating stuff. And look, we've got a couple of questions that have come through, I forgot to say at the very top end, but if anyone has got any questions following Phil's slides and demo, or certainly anything for Andy, we've got a couple of minutes now, so please do pop them into the Q&A section and we can look to get those fielded for you. So right, really just to bring things to a close then. So wireless is now the prime network. I think this is something that we at Mobliciti have been banging drum for some time now, that we will be wireless first, and it's no longer a case of simply guest access in meeting rooms and ad hoc access. And more than ever before, the demands on that network are going to be fundamentally different, with what Andy touched on earlier, with Wi-Fi first, video voice first, laptop first environment. So the demands are changing, and the network's got to be ready to deal with that. So our belief, leveraging technology like Juniper and Mist, can be looking to deploy intelligent, particularly user-centric technology, where we're looking at user-driven service levels as opposed to traditional infrastructure SLAs. And Mobliciti, we can help to support delivering Juniper Mist in a variety of different ways, and more often than not now the dialogue is around Mobliciti running that as a managed service on behalf of the customer to help, as they bridge some of those skills and resource gaps that our clients may have. So that's to bring things on a close there. And whilst I've got you all, it'd be wrong of me not to do a quick shameless plug on just some of the final other areas where we are supporting clients today. Clearly, today's event has been very much focused on everything you can see in that network tier there, but many of you will be familiar with the good work we've done with yourselves from a mobile perspective, a lot of work in the cloud security space as well. But also a lot of depth and capability in supporting clients around getting more out of their Microsoft investment, as well as UC technology and making sure that we can collaborate and communicate effectively, particularly now with the workforce that's going to be split between the usual head office locations as well as working from home. So following today's event, these slides will be sent out to everyone, recording will go out to everyone. So if anything does jump out from there that you think is worth a chat, then get in touch with myself or with your account manager. I'm sure they would be very welcome of a discussion. Okay, so we'll get on to the Q&A. I think to say there have been some questions that have come in. And a couple that seems to be around Marvis as well, Phil. So I'll forward these on to yourself if that's okay. So with Marvis, can it work on non-Juniper switches as well?
Not really. Unfortunately, what we can do is if we have our access points plugged into those switches, we can do some diagnosis on those switches. So we can look for incorrectly configured VLANs, incorrect version numbers, version types on those switches. So anything we can learn from LLDP from those switches, we can pull some information back. But it's nowhere near as extensive. We know the switch is there. We know the switch version and the manufacturer and the power consumption that we're taking from that switch. And as I say, if there are VLANs incorrectly configured or spanning tree loops or those sort of things, anything that's going to impact us, we will absolutely recognize those and we can report on those.
Brilliant, thanks, Phil. And there was a question, I can see that you've answered it on the chat, Phil, but I'll cover it anyway, just in case anyone hasn't seen that. Can the user troubleshoot their own issues with Marvis, or is it purely the IT admin that can do that?
So today it is intended to be an IT admin function. You can actually have read-only access to the platform, so that they could navigate to Marvis and type in their own question. The debate obviously is that if they're having network connectivity issues, asking them to log onto a platform to type in their question is sometimes counterintuitive. But there is certainly plans to do that, and some of our university customers have done that. They've put a little app on the person's mobile phone saying, and they can report a Wi-Fi issue, and it takes the location. We didn't really cover location. We can track location very, very accurately as well. It takes the location of that Wi-Fi issue and reports it back. And if you have a look on YouTube and just type ServiceNow and Mist, you'll see that there's an integration with Siri where you can actually use your mobile phone to raise a ticket on ServiceNow for a Wi-Fi issue, and it gathers a whole raft of information from the handset to put into that service ticket. So the guy just presses Siri and says, raise a ServiceNow ticket, Wi-Fi sucks, and it generates a huge amount of information about that device and his location and everything else, adds it to the ServiceNow ticket along with a bunch of hyperlinks for the support staff to go straight in to see exactly that particular client. So there's lots of integration that's been done, and that's really the power of the platform. Because it's so API focused, third-party companies are making it better all the time, which we're very happy about. The more people using the API and developing guest management systems, guest access systems, utilizing things like our multiple pre-shared key functions, the more people who are doing that, the easier it is for people to choose the best solution off the shelf.
All right, fantastic. Thank you very much, Phil. Well, I think that's boxed off all the questions that were raised. So thank you again, everyone, for joining. If anyone does want a follow-up session or to a bit of an even deeper dive around the Mist AI technology and how it might deliver against some of your needs and requirements, then, as I say, do get in touch with one of the Mobliciti team. absolutely welcome chance to have a one-to-one discussion. But for now, I think we'll finish up 9 minutes early, so time to go and grab a tea or coffee before your next meeting. Thanks, Phil. Thank you, Andy, as always, and look forward to catching up with you all soon.
Thanks for your time, everyone.